Good evening. This is Mr. Morales. I hope everybody's doing okay. Today, this is the first of several handful of videos that deal with polynomials and laws of exponents. We talked already about monomials, and now we're going to talk about binomials and trinomials also. All of them are in the family of polynomials. The first day, we're dealing with adding and subtracting polynomials. Some are binomials, some are trinomials. You should have a packet, okay? Looks like this. You should have your name on it, page 1. I'm actually going to start with page 3. So please turn to page 3 and then follow along with the problems that I'm going to do. So Unit 9, this is day 1. We're going to be adding and subtracting polynomials. Page 3 of the notes packet, which I've already mentioned. The key to adding and subtracting polynomials is to combine like terms. But when you combine like terms, they must have, not only do they have to have the same variable, but they also have to have the same exponent. Let me show you a couple of examples. These are examples of like terms. I have a 3m and an m. Well, 3m and m gives me 4m. They both have an m, same exponent. Here I have negative 6x plus 2x, which equals negative 4x. They both have x's, same exponent. Here, these are examples of not like terms. I have 2x plus x squared. Well, the 2x has an x, and the x has a square on it. Same variable, but not the same exponents. So they are not like terms. Here I have 2x plus 3y. Notice the 2 has the x, the 3 has the y, so they're not like terms because they have different variables. Now, I'm going to start with problem number 1 on page 3. Problem number 1 on page 3. Notice they're lined up vertically, the like terms. So, let's start from the left and go to the right. You should know there's a 1 here. 1 plus 4 is 5. They both have the a's and they both have the squares. We don't change the base or the exponent when you're combining like terms. Here, you should know there's a 1 and there's a 1 here. 1 plus negative 1 or 1a minus 1a cancels out, so there's nothing really there. Now let's look at the third piece here. Negative 3b squared plus, or here plus, 1b squared, we get negative 2, keep the same base, keep the same exponent. So your final answer here could be written as 5a squared minus 2b squared. These cannot be combined because one has an a, the other one has a b. Even though they have the same exponent, different bases. So they're not like terms. Let's go to number 5 now. I have 7a squared minus, this time we're subtracting, so minus 3a squared. 7 minus 3 is 4a squared. This is negative 1a minus negative 4a. So negative 1 minus negative 4, these two negatives make it positive. So it's like negative 1 plus 4, and you get 3a. Lastly, you have 4 minus negative 3. Same concept, those two negatives make it positive. So 4 plus 3 is 7. So there's your answer for number 5. Number 9. All it is written differently. They put parentheses around it, but they're not distributing anything. So you can rewrite this without the parentheses. And what I tell my students is to circle or combine like terms. What goes together? 2x plus 4x is 6x. Now I have 3y plus 9y is 12y. is your final answer. Let's try this one. This time it's subtracting. Now it makes a difference when you're adding and when you're subtracting. In this case, I can bring my second parentheses down and line it up with my first binomial. So I have this binomial lined up together, and I'm subtracting. So 11m minus 2m is 9m. Negative 7n minus negative 6n, again, negative and negative makes a positive, so it's like saying negative 7 plus 6, which is just negative 1n, or in this case, minus n. Last one, number 21. Let's do the same thing. Let's bring this down. But I like to line up my like terms. And again, we're subtracting, so I'll bring this here. There's nothing that goes with d squared, so that's just d squared. Negative 1d minus 2d is negative 3d. And 5 minus 5 is 0. It cancels out. And all my answer is d squared minus 3d. I hope this has helped. Please try to do some of the problems from your packet on the rest of the packet, and let's see how good you do, and we'll go over it in class. Have a great day.